welcome to Mini Tutorials in Spectroscopy. Let's talk about the Zeeman effect. When the total orbital angular momentum has a value greater than 0, a magnetic moment arises. Similarly, a magnetic moment associated with the total spin angular momentum arises when S is greater than 0. The phenomenon whereby these magnetic moments interact with an external magnetic field is known as the Zeeman effect. In the case where S equals 0, the interaction energy is defined by the strength of the magnetic field and the projection of L onto the field axis. Here, the projection of L is defined with the projection quantum number m sub L, and the constant of proportionality is the Bohr magneton, μb. This scenario, where S equals 0, is known as the normal Zeeman effect. In instances where S is greater than 0, we must also account for interaction of the spin angular momentum magnetic moment. We do this by introducing the Landé G factor, which is a function that depends on the spin, orbital, and total angular momentum quantum numbers. This scenario is known as the anomalous Zeeman effect. Let's consider the ground electronic state of a sodium atom in the presence of a 5 Tesla magnetic field. Sodium has a valence 3s1 configuration. Recalling that closed shells contribute nothing to the angular momenta, we see that the ground electronic state is described by a doublet S term. This means that we are describing an anomalous Zeeman effect. We must therefore calculate the Landé G factor for the doublet S1/2 term. Substitution of J, S, and L quantum numbers results in a value of 2. We can then use the anomalous Zeeman energy expression to calculate that the m sub j equals plus 1/2 state has an interaction energy of plus 2.3 reciprocal centimeters, while the m sub j equals minus 1/2 state has an interaction energy of minus 2.3 reciprocal centimeters. Thus we see that the magnetic field splits the doublet S1/2 level into a higher energy m sub j equals 1/2 component and a lower energy m sub j equals minus 1/2 component. I hope that you have found this short video on the Zeeman effect useful. See you next time.